And welcome to another experiment here at the channel. First off, I want to thank Steve Spangler's online science channel. See right here it says Steve Spangler. Thank you very much, Steve, for letting me borrow this experiment. As you guys know, we've been discussing mass and atoms and molecules, and so one of the final experiments that we did in class was we wanted to see, does the air in the room have weight or mass? Now, as you saw in a previous video, we were actually able to weigh gas molecules when we concentrated the carbon dioxide and we put them on the balance and we caused the balance needle to move. Well, in this one, we're going to see if just normal room temperature air made up of nitrogen and oxygen and the other elements actually has mass as you're standing here in your room. This is an experiment you've no doubt seen on YouTube, Bill Nye or Steve Spangler's channel, and it's very simple to create. And the steps are, we're going to need an empty pop can. We're going to need a bowl of water. We have those right here. We're going to put a little bit of cool water into the can. You can probably see the steam. I don't know if you can see this, but there is, there is some steam wafting up out of the cans because I have them on and boiling. And what we're going to do is, as we've heated the water in these two cans, and this is not a commercial for Coca-Cola, it's just one of the cans the kids brought in. As we heat the water in the cans, it causes those water molecules to change from liquid to gas, and it causes them to vaporize and kick out some of the extra air molecules that are inside the can. Because as we know, when things heat up, they expand. So, I have here the two cans where you can see the water wafting. I have a bowl of water, which is approximately 18 degrees Celsius, according to my thermometer. The temperature of this classroom, the laboratory, is right at 23 degrees Celsius. So really not a lot of difference between the air temperature and the water temperature. But what we're hoping will happen is, because we've driven all of these extra air molecules out of the can, that the air pressure in this room is going to push the water into the can. This is going to happen because the air pressure, when we suddenly cool the can, we're going to cause the air around it. There's not enough pressure inside the can to equalize the air pressure, and it's going to implode, much like that. And we have water in the can, and that's because as I put this into the water, I cause the water vapor in the can to suddenly recondense into water, and as things cool, they contract. Well, that caused the air pressure in the can to not be equal with the outside in the room air pressure, and that caused the air out here to implode, because when things shrink in, they implode the can. Also, the air pressure outside drove the water up into the can. The students would want to say that the can sucked the water in. It really didn't. The air pressure pushed the water in. Now, hopefully everybody's ready, because I've got one more can. So here we're going to do it again. One more time. So again, I'm going to turn this over. We still have steam coming out. What happened was the air pressure in here, as I cooled the can suddenly, just this little part down here at the bottom, I cooled the can, I caused the water molecules to recondense just enough that the air pressure is not equal inside the can as it is out here. The air pressure out here crushes the can. As it crushes the can, the air pressure out here on the water drives the water up into the can. Just like that. Now, for our experiment, Because in this particular lab we did the experiment first. The questions were, observe what happens when you put the can in the water upside down. We asked the students to hypothesize what do you think is crushing the can. Even after we've discussed it over and over, we still have some students that aren't quite understanding. In this lab, we've done the experiment first. Exactly what did we do? Number the steps, because we're asking them to remember their scientific method, so we wanted them to number the steps of the experiment. What was the data that we observed up here in number 1? And then how did we confirm that our hypothesis was correct? And I had shown them the video that Steve did and a couple other videos that are available online. But here we've proven that the air here in the room has mass. And we've gotten some cans ready for the recycler in the process. Have a great day, everybody.